Hey space fans! Buckle up, today, we're diving into Venus, Earth's fiery twin. It's beautiful, brutal, and full of surprises. From molten mountains to acid clouds, we've got 50 sizzling facts that will melt your mind. Let's head to the hottest planet in the solar system, starting now. Venus is often called Earth's twin because its diameter is only about 5% smaller and its mass roughly 82% of Earth's, yet its environment is far more extreme than anything on our planet. With an average surface temperature of 464 degrees Celsius, hot enough to melt lead, Venus is the hottest planet in the solar system, even though it orbits farther from the Sun than sun-scorched Mercury. That blistering heat comes from a runaway greenhouse effect driven by a thick atmosphere composed of about 96.5% carbon dioxide, blanketed by highly reflective sulfuric acid clouds that swirl around the planet like a global smog. Surface pressure on Venus is roughly 92 bar, about the weight of a small submarine, equivalent to standing nearly 1 kilometer beneath Earth's oceans, crushing and warping most robotic landers within hours of their heroic arrival. One Venusian day, one rotation, lasts 243 Earth days, but the planet orbits the Sun in just 224.7 Earth days, meaning a Venusian day is longer than its year. Adding to the weirdness, Venus spins retrograde, opposite the direction of most planets, so the Sun would appear to rise in the west and set in the east if you could stand on its surface. Despite rotating slowly, the planet's upper atmosphere whips around every 4 Earth days. Cloud-top winds accelerate to nearly 400 km per hour in a phenomenon called superrotation that scientists still struggle to explain. The thick clouds make Venus astonishingly bright. At magnitude -4.4, it often outshines everything in the night sky except the moon, earning nicknames like morning star and evening star across human cultures. Galileo's telescope in 1610 revealed that Venus shows phases like the Moon, definitive evidence that it orbits the Sun and a revelation that helped topple Earth-centered cosmology during the early days of modern astronomy. In 2012, Venus crossed the face of the Sun for the last time in our lifetimes. The next transit pair will not occur until 2117 and 2125, a rare pattern repeating every 243 years. The Soviet Union's Venera 7 became the first spacecraft to soft land on another planet in 1970, transmitting temperature and pressure data for 23 minutes before succumbing to Venus's ferocious environment. Venera 13 landed in 1982, surviving a record 127 minutes and returning the first color panoramas of the Venusian surface, revealing fractured, pancake-flat basaltic rocks under an orange sky enshrouded by dense clouds. NASA's Magellan orbiter used synthetic aperture radar from 1990 to 1994 to map 98% of the surface, unveiling volcanoes, long lava channels, impact craters, and continent-sized highlands like Ishtar Terra and Aphrodite Terra. Magellan data reanalyzed in 2023 revealed shape changes at event on map Mons, providing the first direct evidence of recent volcanic eruptions on Venus within the past few decades. Further analysis published in 2024 identified fresh lava flows at Sif Mons and Niobe Planitia, strengthening the case that Venus may be as volcanically active as Earth despite lacking plate tectonic recycling. Many surface features called coronae, vast circular fractures, are now thought to mark spots where mantle plumes push upward, hinting at a squishy, mobile lithosphere beneath the crust. Towering above the highlands, Maxwell Mantes rises about 11 kilometers, making it the tallest mountain on Venus and comparable in height to Everest when measured from the mean planetary radius. Because Venus lacks a substantial magnetic field, the solar wind directly scours its upper atmosphere, eroding particles and forming a comet-like tail that streams tens of millions of kilometers downstream. The middle atmosphere, about 50 to 60 kilometers up, has Earth-like temperatures and pressures, prompting scientists to debate whether airborne microbes could survive there after controversial phosphine claims in 2020. At those altitudes, acid droplets create mysterious dark patches that absorb ultraviolet light. UV images from missions like Venus Express show these streaks swirling dramatically around the planet. Lightning on Venus has long been contested, but Venus Express detected Whistler-mode radio bursts consistent with electrical storms, evidence still awaiting definitive confirmation from future probes. Akatsuki, Japan's Venus climate orbiter, finally entered orbit in 2015 after an engine mishap and has since captured striking images of a gigantic bow-shaped gravity wave standing high above Aphrodite Terra. During two 2020 to 2021 flybys, NASA's Parker Solar Probe snapped the first visible light images of Venus's night side, revealing surface glow through the clouds and opening a fresh window on its geology. The joint ESA-JAXA-BP-Colombo mission performed close flybys in 2020 and 2021, gathering ultraviolet and infrared data on atmospheric chemistry and clouds that dovetail beautifully with Akatsuki's global monitoring. NASA has greenlit two ambitious missions, Da Vinci and Veritas, set to launch later this decade to probe the atmosphere in detail and create new high-resolution radar and infrared maps of the surface. Europe's Envision orbiter, approved by ESA in 2021, will carry subsurface sounding radar and NASA's VEN-SAR instrument, promising an unprecedented view from core to cloud tops when it arrives in the 2030s. Engineers dream of aerobots, durable balloon-borne laboratories that could cruise the temperate cloud layers for months, sampling chemistry, photographing vistas, and listening for Venus quakes far below. Venus's brilliant cloud layer reflects about 75% of incoming sunlight, granting the planet an exceptionally high albedo that once fooled scientists into imagining oceans beneath the veil. Although Venus receives roughly twice Earth's solar energy, its surface actually absorbs less visible light because the thick cloud deck bounces most radiation back to space, an energy puzzle for climate modelers. Despite the dazzling reflectivity, outgoing infrared heat cannot escape through the dense carbon dioxide blanket, locking in the catastrophic runaway greenhouse effect that likely boiled away primordial oceans. Isotopic studies show the deuterium to hydrogen ratio in Venus's atmosphere is about 120 times Earth's, implying the planet once held significant water that was later lost to space. Because the solar day lasts 117 Earth days, a human on Venus would see 2 sunrises and 2 sunsets per Venusian year, a rhythm that complicates atmospheric circulation models. Venus's orbit is the most circular of any planet, with an eccentricity of only 0.0068, leading to remarkably steady sunlight and virtually no seasonal variation. The planet's axial tilt is 177 degrees, essentially upside down, so its poles receive similar illumination year-round, and there are no real seasons despite extremely long days and nights on this topsy-turvy world. Surface winds creep along at less than 1 meter per second, yet the dense, syrupy atmosphere means even these gentle breezes can shuffle sand-sized grains and slowly abrade volcanic rocks. Radar images reveal kilometers-long lava channels resembling rivers. Balti's valley stretches over 6,800 kilometers and may have carried extraordinarily fluid basaltic lava across the plains. Pancake domes, flat, circular volcanic mounds up to 25 kilometers wide, form when viscous, silica-rich lava extrudes and deflates, a style rare on Earth but common on Venus. Tessera terrain, crumpled highland plateaus with intersecting ridges and troughs, may preserve the planet's oldest crust and record conditions before global resurfacing erased earlier history. Because craters are scarce and mostly pristine, scientists estimate Venus's surface was globally resurfaced, perhaps by planet-wide volcanic floods, between 300 and 600 million years ago. The discovery of a thin dust ring along Venus's orbit, detected by NASA's STEREO spacecraft, is refining models of how interplanetary dust migrates and accumulates in the inner solar system. Studying Venus helps exoplanet hunters. Telescopes frequently find hot, Earth-sized worlds dubbed supervenuses. Understanding our neighbors' extremes guides assessments of distant planets' true habitability. In 1967, astronomer Carl Sagan correctly estimated Venus's surface temperature using greenhouse theory, showcasing the predictive power of physics for planetary atmospheres and future climate studies. Venus once let astronomers measure the solar system scale. Timing transits from different continents in the 18th century refined the astronomical unit and revolutionized celestial distance calculations. Radar echoes from Goldstone and Arecibo in 1961 revealed Venus's slow, retrograde rotation, pioneering planetary radar astronomy and paving the way for later detailed surface mapping. Future missions aim to drop rugged seismometers that can detect Venus quakes, unlocking clues to the planet's interior structure despite the punishing surface conditions. Engineers are developing silicon carbide electronics that can operate for months at 470 degrees Celsius, enabling long-lived landers such as the proposed Lease station to monitor weather and seismic activity directly. By learning why Venus became uninhabitable while nearly identical Earth thrived, scientists hope to refine climate models and better predict our own planet's future under rising greenhouse gas concentrations. Ultimately, Venus warns that planetary twins can live radically different lives. Exploring our fiery neighbor offers a cautionary climate tale and a stunning opportunity to understand rocky worlds across the cosmos. As new missions converge on Venus this decade, expect a renaissance of discovery that will rewrite textbooks, inspire dreamers, and shed fresh light on how worlds evolve in and beyond our solar system. Despite its harshness, Venus remains one of the most compelling targets for exploration. Its alien beauty, volcanic mysteries, and climate secrets promise to teach us not just about other planets, but about ourselves. And that's a wrap on our tour of Venus. From crushing pressure to volcanic mysteries, this planet is way more than just a pretty light in the sky. If you enjoyed the heat, don't forget to like, subscribe, and share. More cosmic wonders are just around the corner. Stay curious.